So, hello everyone. Now we are going to solve a CF problem, and the problem name is add one. So, first, let's read the problem statement and understand that what is getting asked in this problem. So, for this problem, you are given a integer n, and you need to apply m operations into it. And let's understand that what the operation is all about. So, in one operation, you must replace every digit b. Uh, of the number with the decimal representation of integer d plus 1 means uh, you are given 1912 as an example and it becomes 21023 after applying the operation once. So first let's understand this operation. The number we are given is 1912. Um, so the number is 1912. So we need to represent decimal representation. It is D. Every digit we are given as D. So we need to write decimal representation of D plus one. Sorry for the handwriting. D plus one. So one is here. So when we increase one by one, so it would be two. And when we write the decimal representation of two, so here it would be two. The decimal representation is 2000 actually, but I am writing just the place value of it. Face value. Sorry. I don't know place value, but this means that two would be written instead of one while we generate another number, like the number that we require. So now for n, when sorry 9, when we increase it to uh, by 1 plus 1 because we need to change it to d plus 1. So 9 would be 10, and when we write the decimal representation of 10, so 10 is written, and for 1 similarly, it would be increased to 2, and for 2, it would be 3. So this is our desired number that we need to generate. So this is overall, we count it as one operation. So how many operations that we need to require? We need to uh, apply m operations. And what we need to print. This is the trickiest point of the problem, that you need to always print the length of it, not the number. So for that, we won't be caring about the number itself. Like no matter what number we would be generating, we have nothing to do with it, right? The only thing that we would be focusing on is the length of this particular number. Got it? So have you observed something while I have converted this is to this? That what changed? Also, you have observed this digit, which was the number of digits of 9 was 1 actually, gets converted into 10. Means the number of digits increased by 1. So, in our observation, OVS, what we can tell that for all the number till 0 to 8, when we apply the operation once, they will never change into two digits, right? Means they will never increase the digit. But when the number is 9, So it will increase its digits from 9 to 10 in basically one operation. So the only number now that we will be focusing on is 9. All right. So that was the observation of this problem. So in the solution itself, we would be playing around with 9. So mm, that was it. So now what we are going to do is uh, we'll writing something as BP of uh, I, that would be DP state, and what it means that number of digits, number of digits that, sorry for the handwriting again, number of the digits produced by 9 after, keep this in mind, I plus 1 operations. So if we write dpi of 2, what it means that the number of digits produced by 9 after I plus 1 operations is 2. So let's write the case of n, 1 minute, 1 minute. So let's derive the case n like properly, like what would be happening with n. Then we'll be able to write the code further, like sorry, write the approach further. We are not coding now. So let's move a bit. Let's move a bit, and for 9, first we'll change after one operation 9 will be changed to 10. Then it won't be 11 now because we'll increase every digit by 1 and then we'll write the face value of it, like the decimal representation. So 1 would be increased to 2 and the 0 would be increased to 1. Again, when we increase it, 3, 2, one more time, we'll keep doing it. 4, 3, keep doing it. 5. I want to write all the steps, then we'll be able to understand it better. 6, 5, 7, 6, 8, 7, 9. So if we count from here, how many operations that we have applied till now? 1, 2, 3, 4, 5, 6, 7, 8, 9. So overall, how many operations applied? 9 operations. So what we can say here that from operation 1 to 9, the number of digits that would be produced by number 9 would be dp of I that would be 2. All right. Got it. And one more observation is here, that if we look at the digits specifically, then the number of the operation that would be required for this digit and this digit would be like, there would be a difference of 1, because for this here it is changing to 9 and here 0 is changing to 8. So if this wouldn't have been 9, then we can do one more operations to retain 2 digits. So we can write this as BP. I'm talking about the number of operations. I minus what? 9 and comma BP of, like, sorry, I minus 10. And when we are writing this is still 0 to 8. 1 to 9 operations means iterations would go from 0 to 8. And for BP of 9, like when we apply 10 operations on 9, then the length would be increased to 3. So we'll write it as DP of 9 is equal to 3, right? And for the next cases, like when from the uh, 11 operations to the M operations, the value would be this, like if we write in DP format, this. So all the key points that we have observed till now, we need to code it up. And yeah, it was kind of a trickier problem because, uh, as I already told, that you need to observe few things. First thing that should come in your mind after looking at the example would be this number 9, that we need to play around this number. We need to do the analysis on this number specifically if we want to derive the solution for it. So then you will try to uh, like dry run or illustrate this number, and then then when you convert this number 9 to 10, then you should understand that now the digits has been splitted into 2. So now we need to play with every digit. So here you need to think of the DP, because uh, when we need DP is that when we need to solve the subparts of a particular problem. So for that, here you would need to solve and one case for 0 and another DP case for 1. So for that you would be needing the DP. And then if you are really good, then you guess this by yourself, like how many operations that would be required for 9, like for the number 9 to retain 2 digits, because after the one operation, the number is getting changing its length from 1 to 2. So you need to think of that till how many operations the length 2 would be retained. So all of it. So Then for further operations, you need to write this code. So this will be generating all the further operations. You can try and run it and you will understand that. Let's suppose 20 operations, 30 operations. So for 20 operations, it would be dp of 20 minus 9. What? How much? 11. And this will be 20 minus 10 dp of 9 plus dp of 10. So now solve dp of 9. What is dp of 9? dp of 9 is 3, right? So dp of 9 is 3. And what is dp of 10? dp of 10 will would again be split into this way. And yeah, I hope you understood. So dp of 10, yeah, you can calculate by doing this thing again and again and again and again. So yeah, that was it. And now let's move to the problem. Uh, you have to find the length n after applying m operations. Is the answer can be very large, so we need to print the modulo of it. Okay, fine. Uh, for the inputs, we are given n and m, the initial number of operations. Okay, we need to print the length of the resulting number modulo this value. All. So I think we have understood. Now we should move to the coding part. So now for all the analysis that we did till now. So I am writing inside the compute function. Right. So firstly, uh, we will be needing the maximum value. Uh, for that, we will be iterating. Let's denote as MAX how much the value would be. M is 2 to the power 5. So we need to take something greater than 2 to the power 5. So I think what 2 to the power 5 means 1, 2, 3, 5. So let's write it. So 1, 2, 3, 4, 5. Just greater value than 2e5. So again, let's write the dp vector. 9 plus 1. Right. And inside this, what you need to do is just iterate from for int I is equal to 0, I less than 9, I plus plus, and for all this number of operations on 9, the default value would be 2. I have explained this thing very beautifully. I don't know if it was beautiful or not, but yeah, I have tried my best to explain this. And dp of 9, as I have already told, it would be 3. What is it if we talk about? This is the 10 operation on the number now. Sorry, no, right? And when you increase from 11 operations to max value, let's suppose I plus plus. So for that, we'll be writing dp of I as not plus is equal to dt of I. We need to basically break it up. So I minus 1 plus I minus 9 is 0 and 1 case now. I have told this thing also. I minus 10. So that was it. And in the inputs, we were given n and m, so let's write it. And everything is done basically in the upper half. So we'll be doing everything for specific digits. So let's write the digits is equal to digit as what would be digit n modulo 10. So this will help us to get the rightmost digit. And if the n plus digit value is less than 10, then the answer that we need, let's program to change answer equal to 0. So when this thing will means the number plus digit value is less than 10. Means when we increase the uh, like m plus digit, sorry. When when we increase the digit by applying m operations, still if the digit is less than 10, then we'll increase the like answer by 1 because the length is still 1, right? Else the length, I should write it as length, then it would look like the variable name should be pretty much same with the problem length. Then the length would be increased to dt of digit plus n minus or why I'm writing n again and again. M minus 10. Why minus 10? Because for 10 less than 10 we have handled the case here if statement, and the length we want to go pretty large, so for that we can do here this thing modulo. I think modulo I have already written, yes, there in the constant for balancing constraint. So this thing, and yeah, and all this thing would be happening if uh, one all this thing would be happening when n is greater than 0. And let's copy it here, paste it inside this, because everything will happen when the n is positive. So from that, everything here, and let's do one more thing. Keep getting the digits as like from the right side. So for that, I have written this, and yeah, done. And just it, something like the length of it, and indent. Control S, it should pass. No, it won't. I haven't called the pre-compute. So call it now. Compute. Yes. Control S. I think it should pass. It is not passing. What is the problem with it? Problem with it? Hmm. Length mode. Length is 0. N modulo 10. While N is positive. Why it is not passing? 0 to 9 I have iterated. I have wrote everything as to dt of 9 is 3 obviously. For 10 to max value, I'll increase dp of I as which is causing us the problem. Um, Still, uh, I am getting 5264. Sorry, I should get there's something wrong. Something wrong. The max value is 3 power 5. So 1, 2, 3, 4, 2 power 5. 400. It's a pass. I don't know why I'm not able to see any problem. And M is perfectly denoted. Digit is perfectly written. 1 minute. I need to verify. So I got my mistake. Like here in the code. I was generating the digits outside the loop. Yeah, only once. So I need to write this thing here. Then it will work. I don't know why I do all these things again. So now this is run. Yes, definitely running. Control C. Let's submit it up. Add one. This is pass. I have already submitted this one, but for the video, I'm submitting again. Like submitting it again for the video. Yes, accepted. And yeah, that's all for this video. Thanks for watching. Hope you like the problem. The problem is bit tricky. Yes, that was a very good problem. Yeah, that's all for now. Bye.